Hello guys, my name is Tailbai. In this video I will talk about the performance optimization of database queries in software applications. So let's begin. The first main and the basic question, why is it important to talk about the performance optimization? The first of all is the improved performance. The second is scalability. The third is cost efficiency. The fourth is consistent availability. The fifth is competitive advantage, and the last one is data integrity. All of these things are very important in our application. Let's begin. The first step that I will cover is understanding query performance metrics. So there are some key performance metrics: the execution time, response time, resource utilization. Execution time refers to the duration taken by the database systems to process and execute a query. Response time is the total time taken for a user to receive a response to their query, including network latency, database processing time, and the additional processing on the application server. Resource utilization refers to the consumption of system resources such as CPU, memory, disk, input, output, and the network bandwidth during query execution. The second step is about the query profiling. I will explain it, like I will answer the question what is it, and we will talk about its tools, and the last one is its benefits. So query profiling involves analyzing database queries to understand their performance characteristics and identify optimization opportunities. Like there are many tools for query profiling, but basically we will divide them into two big categories. The first tools are for SQL databases, and the second is for non-SQL databases. Like in SQL databases, we can use command explain for analyzing query performance because it will show us detailed information and we can make some decisions based on it. And the second, NoSQL databases, like there are also many NoSQL databases, and the query profiling tool will be specified based on this chosen database type. I will show you like demonstration example of how these commands work, and I will begin with explain command for SQL databases. You can see on the screen that there is code. It starts with explain, and the remaining is a simple SQL statement. And here is the output. In this example, the type column indicates the access method used by the database engine. The possible key columns shows the potential indexes that could be used to optimize the query. The extra column provides additional information about the query execution. So we can see that the show information is very useful. You can use it to optimize your SQL, your database. The second, query tools for non-SQL databases. In this example, suppose we are using MongoDB as our NoSQL database and I want to profile a query that retrieves documentation from a collection named products. We can use db.collection.explain method to obtain query execution information. And the output will be like this. In this example, the winning plan indicates the chosen query execution plan. The execution states provide detailed execution statistics, including execution time and the number of documents remaining. It also could be useful for performing optimization in our databases. So, its benefits. The first of all, it identifies performance bottlenecks in database queries. We gain insights into query execution strategies and the resource utilization. It also informs optimization efforts to improve query performance and the overall application efficiency. The third step is about query optimization techniques. There are many techniques, but here I listed some key techniques, and they are index optimization, query rewriting, denormalization, caching strategies. We'll cover all of them, and I will also show examples of it. Let's begin with index optimization. Indexes are data structures that enhance query performance by enabling quick data retrieval based on specific columns. And the technique is about identifying query, and the technique about identifying frequently queried columns and they create appropriate indexes to facilitate faster data access. But also, we should note that there is some considerations. We should avoid over-indexing, as it can lead to increased storage requirements and the overhead during data modification operations. Here's the example. Let's consider a hypothetical scenario of an e-commerce website with database backend. We'll demonstrate how each optimization technique can be applied to improve the performance of common queries. Here's the scenario for the first technique. The website frequently retrieves product information based on product category. So we'll create an index on category ID column in the product table. It affects that the queries filtering products by category will benefit from faster data retrieval due to the index utilization. And here's the code. You can see the comparison before index optimization and after index optimization. And it will reduce query execution time due to index-based retrieval instead of full table scan. It's very useful. Let's talk about the query rewriting. Query rewriting involves restructuring SQL queries to improve performance without altering the intended results. We should analyze query structures to identify inefficient constructs such as unnecessary joins, reductant subqueries, or overlay complex conditions. So here's the optimization. We rewrite queries to eliminate reductant operations, minimize the number of table scans, and optimize join sequences. Suppose the website displays a list of recommended products for each user based on their purchase history. So we rewrite the query to use a join operation between the products and the user purchase history tables instead of correlated subquery. It eliminates the need for repeated subquery evaluation for each user, resulting in improved query performance. Here's the code. So you can see that there is subquery for retrieving the data, but we will change it by using join. It reduces query execution time and improves scalability due to efficient join operation. Now denormalization. Denormalization involves adding reductant data to database schema to improve query performance by reducing the need for joins and the data retrieval operations. We'll identify frequently accessed data that involves complex join or aggregated operations. So we'll introduce reductant columns or tables to store pre-computed values or aggregations. Minimize the need for expensive data processing during the query execution. Here are some considerations. We should balance the benefits of denormalization with the trade-offs in terms of data redundancy, storage requirements, and the data consistency maintenance. Let's say the website generates reports on total sales revenue by a product category on daily basis. We'll introduce the normalization table, daily sales summary containing aggregated sales data by product category and date. It reduces the need for complex joins and aggregations during report generation, leading to faster query execution and improved reporting performance. Here's the code. Performance improvement is at faster report generation with reduced query complexity and the overhead. The last one is caching strategies. Caching involves storing frequently accessed data in memory to expedite subsequent access and reduce the need for expensive database queries. We implement caching mechanisms at various levels, including application level caching, database query caching, and the result caching. Optimization is that we cache query results intermediate data sets or entire database tables to mitigate the impact of repetitive queries on database performance. But we should to configure caching strategies based on data volatility, access patterns, and the memory constraints to ensure optimal performance and data consistency. So the website displays a list of top-selling products on homepage, which is accessed frequently by users. We'll implement a caching mechanism to store top-selling products in memory and refresh cache periodically or when new sales occur. It reduces the overhead of querying the database for top-selling products on each home page visit, resulting in faster page load times and improved user experience. Here we are using Redis, and it's the Python example for caching strategies. So performance improvement is faster homepage loading times due to cache data retrieval instead of repeated database queries. And then now let's talk about the performance testing. There are many testing methodologies like benchmarking, A/B testing, load testing, stress testing, regression testing, real user monitoring. It's very important because we have to know the difference between optimized and the non-optimized database. I will show the simple example of testing. Here you can see the original query. Like we just retrieve some information from database and we'll mark the time that it takes. For example, in this case, execution time is 50 milliseconds. Response time is 100 milliseconds. And the utilization is moderate CPU and the memory usage. And here is the after applying index optimization. So you can see that the execution time, response time is decreased. Execution time now is 10 milliseconds, response time is 70 milliseconds. Also, it reduces CPU and the memory usage, which is very useful for us. Here is some recommendation, like it's the summary of my video. First of all, prioritize optimization efforts. Secondly, don't forget about the indexing strategy. Third is query rewriting and the refactoring. Always try to refactor your queries, code. It will improve your application, and in the future it will be very useful for developers and for users, for everyone. And the de-anonymization considerations. Don't forget about de-anonymization. Caching strategies. It's very important. Continuous monitoring and optimization. Knowledge sharing and the training. Collaboration with DBAs. Documentation and the best practices. Performance testing and the validation. So it was my recommendations for you to improve your application. Thank you for your time. Thank you for watching this video. If you liked the video, press the like button and leave the comments. Bye.